In Chapter 12, you're being guided to calculate a dependent samples t-test. This is sometimes referred to as a paired t-test, and by now, if you've been reading your textbook, I'm sure you know that this is referred to as a paired t-test because the scores that are being evaluated are actually pairs of scores. Every subject in the study completes both experimental conditions, the control condition and the experimental condition in which a variable is manipulated. So in the control condition in this study, seniors are exposed to 2 weeks of educational lectures, and at the end of those 2 weeks they're given cognitive tests and one score is produced, one summary score is produced. And then the second condition, in which the seniors are exposed for 2 weeks to social activity hours, and at the end of those 2 weeks they're given a cognitive test that produces one score. So each senior in the study, and there are 40 seniors in this study, in this example we have an n equals 40, and if you want to use a small n you can do that, n equals 40. Each of the seniors completes both conditions. So we have pairs of scores that we're evaluating, and what we're actually evaluating is the difference, the amount of difference that's observed for each pair of scores. And this is very clearly laid out in your book, in your text, so be sure that you refer back to this if you have any confusion at this point about that. All right, so as you know, when we're doing any kind of comparison of groups of scores or samples to populations, we always must have an error term for our denominator. That's how we're evaluating the variability that we observe in our sample. So in the case of the paired t-test, the error term is referred to as the standard error of the mean difference. Now notice we're evaluating only one value, the mean difference value. That is the mean of the differences between those pairs of scores. And the standard error of the mean difference is notated in this way, and it's calculated by taking the standard deviation divided by the square root of n. And then once you have the standard error of the mean difference, you calculate your t value in this way. You take the mean difference that was observed minus the population mean difference divided by the standard error of the mean difference. Now notice something. Because the population mean difference is hypothesized to be 0, we actually don't have to include that term in our calculation, right? We can just drop that because that value is 0. So now t obtained becomes a little bit simpler. It's simply the mean difference divided by the standard error of the mean difference. In order to be able to get to standard error of the mean difference, we have to calculate standard deviation. So here are the 3 little steps that we're going to be doing. We're going to first calculate standard deviation, then we're going to calculate standard error of the mean difference, and then we're going to calculate the t statistic. Now, to calculate the standard deviation, we have to first calculate the sum of squares of the differences, right? And then from there we get the variance, and then as you know, the standard deviation is simply the square root of the variance. So let's start with this. I've copied these numbers from the example in your textbook. If you have any question in your mind at this point about where these values come from, go back a few pages in your textbook and check just to refresh your mind about what these values are saying. So let's calculate this. So sum of squares of the difference equals the sum of the differences squared, that's this value, 845, right? So this is, you sum up all the squared differences, and you subtract from that the sum of the differences, which is this, squared, which is 10,816, divided by 40, right? So let's get our calculator. So if you take 10,816 divided by 40, you get a value of 270.4. Right? And then let's subtract 845, and you get 574. 0.60. So that was pretty straightforward. Our sum of squares of the differences is 574.60, and let's just write that up here. 574.60. This, okay. Okay, now to get the variance, it's just the sum of squares of the differences divided by n minus 1. So this is 574.60 divided by n minus 1 equals 39, right? So let's take this divided by 39, and we get 14.73 rounding. And then the standard deviation is very simple for that. We hit the square root button, and we get 3.84, and let's round that number. Okay, we'll write this out just so you don't have any doubt about where this is coming from. Square root of 1473, and minus 1 is 39, equals 3.84, and we're rounding again, right? Okay, so now we've determined that our standard deviation for the differences, for the mean differences in this sample, is 3.84. So now we can go back. Let's get rid of all this. 3.84. After we've done those calculations. Okay. So here's our value. Now we're trying to get, we need to get the standard error of the mean difference, right, equals standard deviation 3.84 divided by the square root of n. And n here is 40, so let's just do square root of 40 is 6.32. Right. And then we want to do this, 3.84 divided by 6.32 equals 0.61. And once again, we're going to round to 2 decimal places. So our standard error of the mean difference is 0.61. So let's just write that up here. Okay. And now we can easily calculate the obtained t. And here we're going to do the mean difference divided by 0.61, right? Standard error of the mean. And let's just write out that again so there's no confusion. Equals. Now, what was our mean difference for this sample? Was 2.60, right? And we divide that by 0.61, and we end up with 4. Let's see, divided by 0.61 equals 4.26, right? So our t-value in this study is 4.26. Now you're ready to evaluate the effect size associated with this finding and also the confidence intervals.